Hello everyone, I am Anjali Hiremat from Sri Siddheshwar Women's College of Engineering, second year of B Division, Department Computer Science and Engineering. Today I am going to explain a very interesting topic, that is addressing modes of 8086 microprocessor. Let's start. Addressing modes of 8086 microprocessor. Unlocking the power and versatility of the 8086 microprocessor. We will explore how it accesses data for efficient operations. Its mean the 8086 microprocessor supports a variety of addressing modes that define how the CPU accesses operands, that is data. These modes determine the location of the data to be used in an operation, whether it is a register in memory or given directly immediate. Introduction to addressing modes. What and why? What are addressing modes? Method of specify operand location. How the CPU finds data and why. Why they are important? Enhance programming flexibility, improve execution efficiency, crucial for complex operations. Addressing modes in the 8086 microprocessor refers to the different ways in which the location of an operand, that is data, is specified within an instruction. It assembly language programming instruction after need to work with data that may reside in various places, such as registers, memory location, or be included directly in the memory location, or be included directly in the instruction itself. Addressing modes define how the processor identifies the location of this data. They play a vital role in making the instruction set flexibility, powerful, and efficient. By using different addressing modes, programmers can access data directly, indirect, or tough registers combinations of registers and many memory offsets. This flexibility allows for more compact and readable code, better memory utilization, and readable code, faster execution. Moreover, advanced addressing modes like base indexed with the displacement are especially useful in handling arrays, records, and stack structures. In short, addressing modes are essential for efficient data handling and are a key features that support the versatility of the 8086 microprocessor. Immediate addressing mode. Example and use cases. Data directly in instruction. Quick loading of constant. For example, move AX of 05H moves value 5 into AX register. Use cases. Initializing register sitting loop context. It means in immediate addressing mode, the operand is specified directly within the instruction itself. This means the actual value to be used by the operation is embedded in the instruction, not stored in a memory location or register. For example, in the instruction move AX into 05H in the operand and is moved directly into register R1. This mode is commonly used when a constant value is needed in an operation such as initializing register, performing arithmetic with fixed numbers, or setting control values. For instance, add R2, R1 and hash 10 adds the constant value to 10 to the constant of register R1 and stores the result in R2. Immediate addressing mode is efficient because it eliminates the need for memory access, making execution faster forever. It is limited by the size of the instruction format, which restricts the maximum size of the constant that can be directly encoded. Repeat this. It means widely used in situations where small fixed values are required quickly and efficiently. within a program. Next one, direct addressing mode. Memory access explained. Direct memory location. Operand address is explicitly stated. Access specific memory cells. Common application, access global variables working with fixed data tables. For example, move AX into 1000H. Moves content of memory address 1000H to AX. It means in the 8086 microprocessor, direct addressing mode is a method where the memory location of the operand is explicitly specified within the instruction. The instruction provides a fixed offset address, and the actual physical memory address is calculated by combining this offset with the common content of a segment register. Typically, the data segment, that is DS, for example, in the instruction move AX of 1000H, the processor moves data from the memory location at offset 1000H within the DS segment into the AX register. This physical address accessed in computed as DS into 10H plus 1000H. This addressing mode is useful when the exact location of data in memory is known as fixed, such as embedded system, or when accessing memory mapped I/O. It is a simple and efficient for reading predefined constants or configuration data directly from memory. However, it lacks flexibility and is less suitable for dynamic data structures or arrays as it relies on hard-coded addresses. Use cases of direct addressing modes: reading configuration data or constants stored in memory, for example, preloaded lookups tables, predefined values. Accessing variables stored at known addresses, common in embedded systems where fixed memory maps are used. Next, register addressing mode, speed and efficiency. It means register addressing mode is one of the fastest and most efficient addressing mode in the 8086 microprocessor. In this mode, the operand is located in one of the CPU's internal registers such as AX, BX, CX, DX, or other. Since registers are part of the processor itself, accessing data from them does not involve memory access, which significantly reduces instruction execution time. For example, in the instruction move AX BX, the data is simply transferred between two registers without any delay caused by memory fetch cycle. This mode offers excellent speed because it avoids the relatively slower memory burst operations. Additionally, instruction using register addressing tend to be shorter in size, which saves memory space and speed up instruction fetching and decoding. Due to these advantages, register addressing mode is ideal for arithmetic operation, temporary data storage, and situation. Next, register indirect addressing mode, flexibility with pointers. In register indirect addressing mode, in the 8086 microprocessor offers a high degree of flexibility, especially when working with pointers and dynamic data structure. In this mode, the effective memory address of the operand is not given directly in the instruction. Instead, it is held in a register such as BX, SI, DI, or BP. Such acts as a pointer to the memory location. For example, in the instruction move AX of BX, the processor accesses the memory location whose offset is stored in the BX register and moves the content into AX. This mode allows programmers to access memory dynamically by simply modifying the contents of the pointer register without changing the instruction itself. It is particularly useful when working with arrays, string, buffers, or linked data structures, where the data location changes during program execution. The use of registers as pointers also make the code more compact and reusable, improving both flexibility and efficiency in memory access operations. Next type, based addressing mode, array manipulation technique. In base addressing mode of A086 microprocessor is commonly used for accessing elements in arrays and structured data. In this mode, the effective address of the operand is calculated by adding a displacement offset of the contents of a base register, typically BX or BP. The base register acts as a pointer to the starting address of data block, such as an array, and the displacement represents the position of a specific element within that block. For example, in the instruction move AL bx plus 05h, the memory address base accessed in the content of bx plus 5, allowing the program to read the sixth element in the byte array. This approach enables efficient array transfers, as the base address is stored once in the basic register, and individual elements can be accessed by simply changing the offset. Additionally, using BP as the base register allows access to data relative to the stack frame, which is useful in handling function parameters and local variables. Overall, based addressing mode supports structured and readable access to data in arrays and other memory layouts. Next type, indexed addressing mode, string processing example. In indexed addressing mode in the 8086 microprocessor is particularly powerful in processing arrays, tables, and string, as it allows efficient traversal and manipulation of sequential data. In this mode, the effective addressing is calculated by adding a displacement of the content of an index register, either SI source index or DI, that is destination index. The index register typically holds the position or index of an element within an array, while the displacement points to the start of the data structure. For example, the instruction move AL SI plus 04H access the memory location to the data address stands stored in SI plus 4, effectively retrieving the fifth element of a byte array. This mode is ideal for loop based processing, such as copying a string, searching through a table, or performing operations on list of values. The index register can be incremented or decremented inside a loop, making data processing fast and structured. This combination of flexibility, addressing, and loop control makes index addressing mode a strong and essential tool for array-based algorithm and high-speed memory operations. Thank you.